But just to reiterate that we just did our radicals part in the Unit 2 notes. Prior to that, if you recall, that's when we were doing the completing the square. Okay, so trying to just give you the step-by-step that we are doing class by class. And today we'll be solving absolute value equations. And in our next class, we'll be doing the absolute value inequalities. And then we'll test over all that good stuff. So I'm going to change these problems. So let's scratch out that first one and let's do this absolute value equation. 2 plus the absolute value of 5 plus 4x is equal to 11. All right, well, absolute value, remember, means the distance away from 0. And because it's always a distance, it's positive. And so the absolute value of a positive number is positive, and the absolute value of a negative number is also positive. So in solving these, we want to try and get the absolute value part by itself first. So we want to isolate that, much like the radical equation. So this follows nicely, even though it's a totally different kind of problem. It follows the process is pretty similar, where we want to get the absolute value by itself. So I'm going to write the absolute value of 5 plus 4x. I'm subtracting 2 from both sides is equal to 9. Okay, so I just subtracted the 2 over. And now, this stuff that's highlighted right here, okay? Remember, absolute value means we're going to take the positive of that. So that means that the highlighted stuff could either equal positive 9, or the highlighted stuff could equal negative 9, and the statement would be true no matter what. So we have to set up 2 equations. So once you have the absolute value by itself, we then split it into 2 equations. So you get the absolute value by itself first, and then I'm going to write 5 plus 4x, the stuff inside there, that could equal negative 9, or 5 plus 4x, the stuff inside there, could equal positive 9. So again, we got the absolute value by itself, and then we set it equal to negative of the equals and positive. And then we just solve those. So I'll subtract the 5 from both sides. So I have 4x is negative 14, and x is negative 7/2. And on the other side, 4x is equal to 4. And so x equals 1. All right, now, like before, we again want to check for extraneous solutions.
I have a question.
Yes.
Isn't it the second equation, 5x plus 4x equals 9? Oh, shoot, never mind. I think I messed it up.
Good?
Never mind, you're good.
Okay. All right, so we want to check for an extraneous solution. So let's take negative 7/2 and let's plug it into there. So we have 2 plus the absolute value of 5 plus 4 times negative 7/2. And we're trying to see if that equals 11. So when we do the 4 times negative 7/2, we can reduce that to 2 and 1, right? I'm going to shrink this guy down a little bit because I'm running out of space. So I have 2 plus the absolute value of 5 minus 14 is equal to 11. 5 minus 14 is negative 9, and the absolute value of negative 9 is positive 9, and so it checks out. So negative 7/2 works. Now let's plug 1 into there. So I'm plugging 1 in for x. Maybe change colors here. So we have 2 plus the absolute value of 5 plus plugging a 1 in there. So 1 times 4. And seeing if that equals 9. Oops, I'm sorry. If it equals 11, my mistake. Okay, plugging it into the top here. And so we get the absolute value of 9, which is 9 plus 2. It does equal 11. And so then that one also works. Okay, so
I have a question.
yes.
Can't we plug it into the reduced form when we subtract 2 over? So then it's the absolute value of 5 plus 4x equal to 9?
Yeah, you could do that as well. Yeah, so the question was, could you, I plugged it into the original. You could plug it into here also. I like plugging it into the original just in case I happen to make a mistake in that first step. But either one should work, of course, because they are equivalent equations.
Wait, but if we were going to use the reduced form, would we, but equals to 9 or negative 9? Or do we put both of the answers into 2 separate equations?
No, you would plug it in into the second one, and it would have to equal 9.
Okay.
Okay? Yeah, good questions, guys. All right, let's do another one. So we have the opposite of the absolute value of 4x plus 3 plus 3 is equal to negative 6. So I want to get this absolute value stuff by itself first. So I'll move this to the other side, move that 3 over. So I have the opposite of the absolute value of 4x plus 3 is equal to negative 9. And then I'm going to divide by negative 1. So I get the absolute value of 4x plus 3 is equal to positive 9. So first part of the process, we want to get the absolute value by itself. Then just like we did over here, then we want to split it into 2 equations. Because again, this stuff in here could either equal negative 9 or positive 9, and it would still be a true statement. So I have 4x plus 3 is equal to negative 9, and 4x plus 3 is equal to positive 9. And then we want to solve both of those to get our 2 answers. So we have 4x is equal to negative 12. And x comes out to be negative 3. That's one of our answers. And we get 4x equals 6 on the right side. So x equals 6 over 4, which is 3 over 2 on the right side. All right, and I'll check those in just a second in case you're still writing. And I'm going to plug those back in, of course. So if I plug negative 3 in, I'll do the absolute value of, the opposite of the absolute value of 4 times negative 3, which is negative 12, plus 3, and then plus 3, which equals negative 6. And so this part, I have, that is going to be the absolute value of -9, which is +9. But then don't forget we have that out in front. So I have -9 plus 3 equals -6. And that one checks out. So our -3 worked. For our next one, I'll plug in 3/2. So I'll do the opposite of absolute value of 4 times 3/2 plus 3. So again, I'm plugging it in here. So plus 3 and then plus 3 is equal to -6. So inside here, that's going to become 2. So that's the opposite of the absolute value of 6 plus 3 is 9. Plus 3 equals -6. And it looks like that is going to work out. So I get -9 plus 3 is -6 again. So we're in business.
I have a question.
Yes.
Is this checking that we're doing the same thing as the solving like the radicals? Because like, are they supposed to check out, or is it like the radical one? Like we're looking to see if they're like if it makes sense.
Yeah, good question. There are cases, yes, they are supposed to check out, but there are
Mhm.
cases where there are extraneous solutions. Let's take a look at our next example, okay? So
Okay.
you're right on par with what we're doing here. So for our next example, again, I'm going to get rid of this, get rid of this. So let's say we had the absolute value of 4x minus 9 is equal to 5x. All right, well, the absolute value in this case is already by itself. So I'm just going to immediately write my two equations. So this stuff could be 5x or it could be -5x. So those are my two equations. That 4x minus 9 could be -5x, or 4x minus 9 equals positive 5x. So I'll solve both of these independently. So I'm going to move the x's to the right. So I have -9 is equal to -9x. So x comes out to be 1. And if I move those x's over, I get x equals -9. And so I have two answers of 1 and -9. So when we plug them back in, hopefully they do work. We're plugging 1 in for both x's now. So I get the absolute value of 4 minus 9 is equal to 5 times 1. That is a true statement, because 4 minus 9 is -5. The absolute value is +5, so that works. Now we'll check -9 and plug that in. So that's going to be the absolute value of 4 times -9 is -36 plus 9 is equal to -9 times 5, which is -45. Oops, I wrote plus 9 here. Sorry, guys, that's a minus 9.
I don't understand. How is it negative 45? I thought it was equals to 5.
Let me rewrite that, and I'm going to write it in another color, but you're correct. I'm just rewriting what I just wrote. So it's 4 times negative 9 is negative 36 minus 9. And we're trying to see if it's equal to, I plug negative 9 in here and here. But that is not true because the absolute value of negative 45 is not negative 45. Therefore, negative 9 is an extraneous solution. So they don't always check out. Getting back to your question.
So
All right.
basically, we're doing the same thing as last time, except with absolute value.
Yeah, exactly. Yeah, we're just checking them just like we did before with the radical equations. Yep,
So this one will be only x equals 5. I mean, x equals 1.
correct. All right, so let's do one more. I'm going to put this in below here. It's going to might take a little bit more space. So let's say we had the absolute value of 3x plus 2 minus 6 is equal to 5x. All right, well, the first thing we want to do is get the absolute value by itself. So we have absolute value of 3x plus 2 is equal to 5x plus 6. I just moved that negative 6 over. Now this one gets a little more tricky. Because once the absolute value is by itself, remember, this stuff on here can equal whatever's on the right side, and it could equal the opposite of whatever's on the right side. So we have our two equations. 3x plus 2 could equal the opposite of 5x plus 6. Or 3x plus 2 could equal the positive of 5x plus 6. So again, I wrote this equals negative this, and this equals positive this, just like we did before, but it's a little different because we have variables on both sides. So I'll solve both of those. So 3x plus 2 is negative 5x plus 6. Get my x's on one side.
Is it a negative 5x minus 6 because you're distributing the negative?
Thank you. I almost missed that. You are correct. Negative 5x minus 6. Because you have to distribute your negative. You are right on. And so I have 8x is equal to negative 8. And x comes out to be negative 1. And on the right side, I'll move my x's to the right and numbers to the left. So I have negative 4 is equal to 2x. So x equals negative 2. So we have two potential solutions of negative 1 and negative 2. So when we plug them in, I'll plug -1 in first. So I have the absolute value of 3 times -1. That's -3 plus 2, and then -6. Does that equal -5? Well, this part is the absolute value of -1, which is 1 minus 6, which does equal 5. I'm sorry, 1 minus 6, which does equal -5. So this is one of our solutions. And now I'll plug -2 in for the x's. So I have the absolute value of 3 times -2, which will be -6, plus 2, and then -6. And we're trying to see if that equals -10. This is going to be +4 because the absolute value of -4, which is +4, and 4 minus 6 does not equal -10. Therefore, -2 is an extraneous solution.
I still don't understand why you keep putting -10. Isn't it supposed to be 5? Because we're plugging it into the original solution.
Plug it into the original equation. So we plug -2 in for x here, right?
Oh,
So-
you got to plug that into x?
Yes, and for
Oh.
x. Yeah. So it's 5 times -2. That's where the -10 comes from.
Thank you.
Okay. All right. Any other questions?